Welcome, my dear students. So today I am going to solve some of the interesting problems based on the concept of force experienced by a charged particle under the presence of magnetic. Let us start with the first one. So in this situation, it is given that the magnetic field is acting along the x direction as v naught into I. And the velocity of the particle is given as 3I plus 4k. That means it has a x component of 3 velocity and z component is 4 meter per second. And you are asked to calculate the coordinate of the particle having a charge of q and mass is m when released from the origin after time t. Okay, so particle is released from the origin and particle is moving under the presence of magnetic field, so it will experience a force. So every time try to draw the diagram based on the concept that since B is given as B naught into I, so make sure that I is either dot or cross. So if I represent the x coordinate as cross component of the axis, then y will be vertical and z will be the horizontal. So first try to draw this diagram. Okay. So under this diagram, so B is acting along the x direction, that means it is cross. Now since the particle is projected with a velocity of 3 and 4 along the x component and z component, so x component of velocity will not experience any kind of force. Why? Because this x component of velocity is parallel to the magnetic field. So force on this particle along the x direction is nil. Only the force will be there along the y direction. Why? Because the velocity is along the direction of 4. So here the particle velocity is 4 meter per second. Because of that, it will perform a circular motion. In a yz plane, there is a circle like this. So what is the radius of the circle? The radius of the circle is equals to, I know that mv by qb. This is the formula. Okay. Now v is 4. So 4m by qb. So 4m by qb is the radius of the circular track. Now because of this circle, I know that the particle is moving in this direction. So let us say at any time t the particle is over here. So this angle is how much? Then omega t. Okay. So corresponding to that, what is the y component? So y component should be equals to r into 1 minus cos of omega t. Okay. Similarly, z component is how much? Z component is equals to r sine of omega t. And what is the x component? X component is simply our 3t. Okay, so these are the answer. The only thing is that you put the value of r and omega. Now what is omega? Omega is equals to how much? 2 pi by capital T. Third time period. So what is time period? So 2 pi by 2 pi m by qb. Okay. So ultimately what I am getting? qb by m is our omega number. So once I got this omega, I know the value of capital R, so I can calculate all the coordinates. So these are the coordinates of the particle after time t. Okay. Now moving on to the next problem. Here the magnetic field is variable. So magnetic field is acting along the z direction, negative z direction. So that means it is into the plane of paper like cross. Okay. So magnetic field is cross field. So it is given as minus v naught into x into t. So it is a variable. Now once I project a particle, so it will experience a force along this y direction. It will experience a force along the y direction. So particle will deviate, and ultimately the path of the particle will be like this way. It will go on moving like this way, and ultimately once the particle becomes parallel to the y-axis, with a velocity v naught, and that is the maximum displacement of the particle along the x direction. So you are asked to calculate this x max number, xm number. Okay, what is the maximum position or the displacement of the particle along the x? So that you have to calculate. So at any instant, if I project the particle with a velocity v naught, so can I say the force acting, the magnetic force acting on the particle is equals to q into v naught into v naught into x. That is the force acting. Okay. So that component of force is always perpendicular to the direction of the velocity. Let's say at any instant you are saying that velocity is in this direction with the velocity of v naught, and at that instant the magnetic force is in this direction Fm. Let us say the angle with the horizontal is, let us say this angle is alpha. Okay. So correspondingly this angle is 90 minus alpha, so this becomes alpha also. So y component of the force is Fm cos alpha. So can I write F along y direction, that is equals to our Fm cos alpha. Fm cos alpha. Corresponding to this, what is the acceleration along y direction? Acceleration along y direction can be written as Fy divided by m number, mass of the particle. So that means equals to Fm cos alpha divided by m. If I put the value of Fn, so what I am getting that is equals to q into v naught into v naught into x cos alpha and divided by a. That is the acceleration along the y direction. Now this acceleration along the y direction can be written as basically our dvy dt number. dvy dt, how the velocity along the y direction is changing with the change time. So dvy dt, can also be written as the dvy dx into dx dt. And that number is equal to how much? Q into v naught into x cos alpha divided by m. Now what is dx dt number? So this dx dt is nothing but the rate of change of position of the particle along the x direction. That is basically the component of velocity along the x direction. So that is our vx number. Now what is vx? So vx is v naught cos alpha. So this number is nothing but our velocity along the x direction, vx number. Okay, so Vx is what? Vx is basically our V naught into cos alpha. So V naught cos alpha, that is the x component of velocity. If I substitute this, so ultimately I am getting dvy dx into V naught cos alpha That should be equals to our q into V naught into x cos alpha by m. So ultimately this V naught cos alpha and from the both sides cancels out. So this V naught cos alpha cancels out by this number. Okay, so ultimately I am left with q into v naught into x by m. Okay, so ultimately, what is the expression? That is dvy dx should be equal to that number. Okay, so now I have to integrate it. So if I say dvy, that should be equals to q into v naught divided by m, q into v naught into m into x into dx. So if I integrate it, so starting velocity here, once it projects the particle, velocity is only along the x direction. So velocity along the y direction is 0. So it will bend until and unless velocity becomes always parallel to the y axis. That means only the v naught component will be there. So at this point, there is no component of vx. So vx should be equal to 0. So this is the maximum position of the x direction. So starting from 0 to v naught, initially the x is how much? 0, and finally I am getting the xm. So that means q v naught by m into x max square by 2, that should be equals to our v naught number. So what is the xm that I am getting? Xm equals to how much? 2m into v naught divided by q into v naught whole root. Okay, so this is the maximum displacement of the particle along the x direction. Okay, so this is how you have to approach this problem. So every time whenever this type of situation comes, so try to calculate the velocity along the x and y separately and try to analyze the problem, how the problem is given or what are the conditions that you have to use. Moving on to the next situation. So there is a long straight wire, carries a current of I, and a particle at point P is projected with a velocity v towards the wire at a distance of x naught. Now, once it is being projected, so it will be again deviated under the presence of a magnetic field, and you are asked to calculate the minimum separation between the wire and the particle. So, what is happening in this situation? As the particle is approaching towards the wire, so magnetic force will act, and magnetic force will act in this direction at an instant. So, ultimately, it has one component along the y direction and another component on the x direction. Okay. So, this y component of this creates the acceleration in the y direction, and ultimately, the particle will approach up to this distance until and unless the entire velocity that has been projected along this direction becomes the parallel to the y-axis. Okay. So at this point, I want to get the velocity which is parallel to the y-axis. So that is the condition. So let us start with this. So at any instant, if I project the particle, so let us say the magnetic field due to the current carrying wire should be how much? That should be equal to mu naught I by 2 pi into x at any x location. Okay, that is the magnetic field acting on this particle. So because of this magnetic field, what is the force acting on the particle? Magnetic force should be equal to q into v naught into mu naught I divided by 2 pi x. So v naught is the velocity which the particle is being projected. So this is the velocity v naught. Okay. So that velocity is not going to be changed. Only thing is that the magnitude is not going to be changed, but the direction is changed. Okay. So this is the force acting. So at any instant, let us say this is the situation of the particle. Particle will deviate like this way. At any instant, if you say the v naught is acting in this direction, and let us say this angle is alpha, and force is in this direction, Fm. Okay. So component of this force along this vertical direction should be how much? This component is force along the y direction. So that angle is again alpha. So Fm cos alpha. Fm cos alpha is the force acting in the y direction. So that acceleration along the y direction can be written as acceleration along the y direction, that is equals to Fm cos alpha divided by m. Now what is that number? That is basically q into v naught into mu naught by 2 pi x into current I into cos alpha divided by m. Okay, so that is the acceleration of the particle along the y direction. So that acceleration can also be written as our dvy dt, change in velocity along the y direction, rate of change of velocity. Now dvy dt can further be simplified as dvy dt can be further simplified by saying that it is equals to dvy dx into dx dt. Now what is dx dt? Dx dt is the velocity along the x direction. Okay, so dx dt is nothing but the velocity along the x direction. What is that velocity along the x direction? So that component is basically our v naught cos alpha again. Okay, so similarly I can write that q into v naught cos alpha into mu naught into I divided by 2 pi m into x. That number is equals to dvy dx into dx, that is v naught cos alpha. Okay, again this v naught cos alpha and that v naught cos alpha cancels out. So I am left with this number dvy by dx. So dvy dx, that should be equals to our q into mu naught into I by 2 pi m into x. Okay, that number. Now if I rearrange this, so ultimately I am getting dvy, that should be equals to q into v naught by 2 pi m into dx by x. Now once I do the integration, so integration of this number and that initially at once we start the particle, so x is x naught. Now after some time the particle is at a distance of xm, minimum distance. I want to calculate this minimum distance. So limit is x minimum. Once the particle is at a x naught location, so velocity along the y direction is 0. And finally the velocity along the y direction that I am getting is minus v naught. Why? Because it is in a negative direction. So once you put the limit and finally you calculate it, so it becomes minus v naught should be equals to how much? Q v naught divided by, so q mu naught, not v naught, q mu naught. So this is mu naught divided by 2 pi m into ln x, and the limit is x minimum divided by x naught. Okay, so finally what I am writing that x minimum should be equals to how much? X minimum should be equals to x naught into e to the power minus 2 pi m into v naught divided by q into mu naught into I. One I will be there. Okay, that I is there. So that is the final answer. There is the minimum separation between the particle and the infinitely long wire, which is carrying the current. Okay, so this is how you have to approach the problem. So these are the typical problem where you have to apply the concept of both the magnetic force and how the particle is moving. Okay, so depending on that, you have to formulate the problem accordingly. You have to get the result. Hope you understand this. If you like it, please subscribe my channel. Thanks for watching.